Today, I'm going to talk a little about the disaster that's happening in Maceió in the state of Alagoas. Hello, mothers of engineering. Surely, if you follow the news and the internet, you must have already heard about what's happening in Maceió. A lot of people have been talking about the subject, but it's a bit hard to understand both the impact this can cause and what's really happening. But before we talk about the subject, take the opportunity to subscribe if you haven't already, leave your like and activate the notification bell. And if you find our content interesting, would you consider becoming a member? To help us keep producing content here on the platform and to be remembered in our videos. So let's go. To understand what's happening, we need to understand things from the beginning. In 1943, a geological and prospecting study was conducted in the Alagoas region to find oil. But at a depth greater than 850 meters, another item was found that could also be valuable: rock salt. But even knowing about the existence of this deposit there, it was only in the 1970s that, by a presidential decree, the extraction of this rock salt was authorized. At the time, the company that started its extraction was Salgema Indústrias Químicas S.A. But what is this so-called rock salt? This mineral is mainly composed of sodium chloride with concentrations of potassium chloride and magnesium chloride. It is also known as fossil salt. In a very simple way to explain, if we evaporate seawater, we get salt, which, through the necessary precipitation processes, forms a mineral called halite. Now imagine this halite being deposited in layers upon layers over millions of years in ancient marine basins. Over time, these layers will become a very compacted material due to the high pressures, and eventually it will become what we call rock salt. It's important to point out that this rock salt is formed over millions of years, and it can be found both on the Earth's surface and in deeper layers, depending on the region. But why do we want to extract this rock salt? This material is widely used in the production of chlorine, caustic soda, hydrochloric acid, and even sodium bicarbonate. Polyvinyl chloride, which we use in pipes and fittings in the plumbing of our homes, also uses rock salt as a raw material. But that's not all, because we can also use it in the pharmaceutical industry and for personal hygiene, like in the production of soap, detergent, and even toothpaste. Other industries, such as the paper and pulp industry and the glass industry, also use rock salt as a raw material in some of their processes. Okay? But what does this rock salt have to do with what's happening in Maceió? To understand the connection between rock salt and the ground collapse in Maceió, we need to understand how this material is extracted. I said that back in the 1970s, the company Salgema Indústrias Químicas S.A. started operations in Alagoas to produce dichloroethane. This company eventually changed its management and in 1995 changed its name to Trichem. There in 2002, Trichem merged with other companies in the sector, forming what we know today as Braskem. When Braskem turned 10 years old, it opened a polyvinyl chloride factory in Marechal Deodoro, which is a neighboring city to Maceió, and this accelerated the extraction processes and economic incentives in the region. Well, there are two ways to extract rock salt. If the layers are more superficial, like in a large area, they are mined with direct extraction since it's easier to extract them. Now, if it is found at greater depths, its extraction is done by a method we call solution mining. We need to understand that rock salt, just like our table salt, can be dissolved in water, so if we pour water on rock salt, it will dissolve. Since the rock salt in the Maceió region was at great depths, over 850 meters, the solution mining method was chosen, and it is still used today. To carry out this dissolution, basically, we make a control well, which is drilled until it reaches the rock salt deposit, and once at the deposit, water is pumped into this well. So once the water reaches the rock salt, it dissolves in the water. But once that water is down there, it has nowhere to go. It simply returns through the control well. In other words, you pump water into a well. The water dissolves the rock salt into brine, and once the well is completely filled, it starts to overflow this brine through the control well. It is then collected and taken to a processing plant for treatment and refining of the material. Like in the production of dichloroethane, which is a raw material used in the production of polyvinyl chloride. Well, the whole point is that this process creates a problem. In fact, a big problem if it is not handled properly. When the entire rock salt deposit is extracted, in the end, we simply have a large void filled with water. That's right, the rock salt layer is removed, and in its place there's only the water that was used. And this water can still seep into the ground, leaving a void. This void can cause instability in the ground, in the region where the rock salt was extracted. That's because the ground loses its load-bearing capacity. To fill the void left behind and prevent the ground from becoming unstable, it's necessary to fill the rock salt deposit with another supporting material, such as sand, for example. But this process isn't quick and is carried out over the course of years. The big problem here is when the underground layers lose their supporting capacity and simply collapse into the void formed by the deposit. And that's exactly what's happening in Maceió. Since we have a large void in the underground layers due to the extraction of rock salt, the layers above this void are collapsing and caving in. This causes seismic tremors, and eventually the surface soil starts to give way and collapse as well. But in the extraction process, it's not just a single well that's made, but several in strategic locations. The problem is that when the extraction deposits from these wells meet each other, you simply connect one problem to another, linking the wells with a large underground cave. But besides that, there's another problem. There is a soil analysis that determines the strength of the upper layers above the deposit to see if they are strong enough to support the weight of the soil above, the houses, and the entire city on top of it. But once we have collapses happening underground, seismic tremors can create stress in the soil, making it unstable, and as a result, it could collapse all at once. If you've ever worked on a construction site with a pile driver, or lived next to a site that used this equipment, you know that the simple shaking caused by that machine with its vibrations can already cause cracks and fissures in houses. Now, imagine an entire layer of soil, millions and millions of cubic meters of earth falling into a pit and producing a huge impact in that void. It's as if an earthquake happened that would shake the whole region and could cause a domino effect in other layers of pits in nearby wells. And that's another problem in Maceió. The ground is collapsing into the void left by the extraction of rock salt, causing seismic tremors, which is leading to landslides and the sinking of part of the city. But there is something that can be done. Well, if the extraction well site can still be accessed so that the void in the ground can be filled. Ideally, this filling should be done, and from what I could see, it is actually being done. Now, if at some point there was a collapse that prevents the entire void from being filled, and it was only possible to fill part of the void, then you just have to wait, because Mother Nature will take her place and fill that void with soil in a major seismic shock and soil collapse. The company even took control and mitigation measures for this problem, installing piezometers, inclinometers, and even seismographs to monitor any seismic activity in the region. But controlling this void left underground in a place that you can't access, hundreds and hundreds of meters below the surface, is an extremely complex and difficult task. At a certain point, it's almost certain to say that the ground will collapse, but predicting when that's going to happen is what's uncertain. Unfortunately, we are seeing the appearance of a crater on the surface and the filling of the void left underground in Maceió. I'd like your opinion. What do you think will happen in this region? What impacts do you think could happen? Some say it will be the biggest environmental impact in the world. Do you think that's true? Comment below, I'm interested. Here on the side, there are 2 videos that you might also like and that will help you increase your knowledge. If you want to support us, just leave your like, subscribe to the channel, turn on the notification bell, and if you can, consider becoming a channel member. That's it, engineering lovers, a big hug, and I'll see you in the next video.